All right, so we're going to talk about angles. The first thing you want to do is know the definition of an angle. An angle consists of two different rays that have the same end point or same initial point. Either one would be fine. So it consists of two different rays that have the same initial point. This initial point is called something special. Can anybody guess what the initial point would be of this? A, yeah. So there you go. So we actually call this a vertex. We'll talk about it in a second. What I want you to write for the sides of an angle, I want you to just write rays. R-A-Y-S. R-A-Y-S. So you see how it says sides of an angle? Rays. R-A-Y-S. All right, so it's consisted of two rays. They're called ray A-B and ray A-C. All right, and then we call this a vertex. So the initial point we call the vertex of an angle. So a vertex of a polygon is the corner of the polygon. A vertex of an angle is the corner of the angle. You can name this angle three ways. And it's going to ask you on your classwork tomorrow to name this angle three ways. All right, so the first way you could say, pause. I want you to write at the top of your paper this symbol. Looks just like that. Looks like Ash Ketchum's hat. Y'all know what I'm talking about?
Oh, wow.
Doesn't it? You're welcome. Well, if it doesn't to you, then it is what it is.
Then you need another child.
Then you need another child. That's exactly right. So this is an angle symbol. We always write angle. No matter what, we write angle, and then we'll name the angle. Okay, so three ways to name it. First way is C-A-B. So whenever you name an angle, you want to act as though you're outlining the angle while you're naming it. So C-A-B. The second way you can name it is B-A-C. Does anybody notice the similarity between these two names, other than the symbol?
They have the same. They go it's backwards.
Well, it is, but no. What else?
A's in the middle.
A's in the middle. Well, what's A?
The angle. No. The
Phone a friend?
yeah, I don't have a friend.
I got it.
It's the initial point called the
Vertex.
vertex. The vertex is in the middle. So the third way that you could name this is, angle A. So you can name it either with A in the middle of two letters, so C-A-B, B-A-C, or you could straight up say angle A. Okay, so those are three ways to name an angle. You're going to be asked this, but we're not going to name it this way the rest of class. So make sure you remember it. I'll explain why we're not going to name it with angle A on our first example. Okay, look at this. You see this on your notes. It is in the middle of the page to the right. Can I get an amen? You see what I'm talking about? Amen. Amen. All right, so we're going to name this first angle in green. You don't have to color code them, but I will. When you name an angle, the first thing that you write is the angle sign. All right, so then you want to look. This angle goes from this ray with QP and then QS. So you want to start at the very outward point. So P, go towards Q, and then go out towards S. Okay, is there another name we could have named this?
SQP.
SQP. SQP. It's okay. Nope. I'll explain in 2 seconds. All right, if we have this blue angle, you see, from this ray to this ray, all right, what is one way we could name this, Jerron? SQR, I agree. Go ahead and throw it to a friend. SQR. What is another way you could name it? I would just throw it to someone. Just throw it to someone.
RQS.
RQS. All right, and then the last I'm going to put in purple. Name the large angle at Q. Or the Q. The purple angle. RQP, I agree. Throw it to a friend who would. Not Duran. There you go. Cole. Can you name it the second way?
What's the question?
We're naming this purple angle.
Which one do you want me to name? Oh, the purple one?
Yeah, the purple one right here.
Yes,
P. Not PS. You're close.
S,
Nope, you can't use S. We're naming this outer angle. We're not using letter S. You're naming this angle totally. PQR. I agree. It's okay. So, what have you noticed about what we're not naming these? Q? Why aren't we naming it Q? I can have it back. What do you think? Why are we naming it Q? What do you think? You have a guess?
Maybe it's because it's in the middle.
It's
First, no, it's 2 angles.
It's actually 3 angles, but yeah, you're on the right track. So Q is the vertex of this green angle, it's the vertex of the blue angle, and it's the vertex of the whole purple angle. So because it's involved in 3 angles, you can't just say Q, because I would have no idea which one you're referring to. That make sense? So whenever there's more than one angle, you have to use 3 letters. Okay? All right, so we're going to talk about some terms that are kind of like obvious. What do you think it looks like when a point is on the angle?
Point.
Anybody can say it.
A point.
Okay. I don't even know what to do with that. Point is on the angle. What do you think it looks like? A dot where?
On the line.
On the ray. Okay.
Oh.
On the angle means all the points that lie on the rays that make the angle. So you can have a point here. You can have it over here. You can have it up here. You can have it here. Here. Okay. A point that's on the angle. What do you think interior means? Anybody?
Inside.
On the inside of an angle. And then what do you think exterior means?
Outside.
On the outside. So it's not on the inside and it's not on the angle. Therefore, it is outside.
You need to write it down.
All right? No, it's just kind of common sense, but I want to make sure that we hit it all. All right, go ahead and do example 1 on your notes. It is in the center of the page. It says example 1. It is a lighthouse. I'm going to ask the people who don't look like they're doing it. So go. All right, we're going to name our first angle. Reed, can you name the angle I've highlighted in purple? Yep, JMK. You can throw it to a friend who can name the other inner angle.
That was left. Chill out. JML.
JML. Would you like to try again?
Is that
The yellow one? The one I've highlighted in yellow.
KML.
KML. All right, and then throw it again to a friend or non-friend. I don't care. Who has it? Duran again. Duran, throw it again. I love you, and I love that you're cooperating, but... Hey, look, she wants to play. Look at that. You're good. Don't throw it at someone. Throw it to someone. Michaela, what you think? JML, Jamal. Sweet. Here are the 3 ways to name them. You can reverse any of the letters to KMJ, LMK, or LMJ. All right? But these are the answers. All right, we're going to talk about this. We're on to the second portion of the lesson, and it's about protractors, how to read them. What do you think the M stands for in front of this angle sign? Wow, that's good. No, that was good. Measure.
Whoa.
So here's what I want to point out to you. Do you see the measure of angle A? This little, it looks like a less than sign? It's because it is. So I'm just going to put out the preface that whenever I make an angle, I have to go to Google, and I Google angle symbol, and then I have to copy it and paste it onto a PowerPoint. So there are times where you'll just see this less than sign. Just pretend that it is an angle. Are we all okay with that? Okay. Andrew, are you okay with that? Because you don't seem to be listening. Good. Okay, so when you find a protractor, if you want to look at one that's not so blurry, there's one on your notes at the very bottom. What is written in this left section? What's on the top? What's the top number? 0. Y'all. 0. What's the bottom number? What I've circled. 180.
I thought you were talking about the 90 at the top.
I said the very bottom.
Oh.
I'm glad we're good at listening. And then the other side, you see the numbers 180 and 0. Okay, there's a reason for this. What you want to do is you'll see my angle. It's in blue on the screen. My angle is lined up with the 0, meaning if you look at the ray, do you see this 0 right here?
Yeah.
I know that it's blurry, but... So that means to find the measure of the angle, you would read all the way up until the other ray, which stops here. But since the 0 was on the bottom, you need to read the bottom numbers. So where does this angle stop? 50. So the measure of this angle would be 50 degrees. Whenever we do this, we would put the little dot just like you would when it's 100 degrees out. You know, the little dot means degrees. So we use here. So there's that way to do it. There's a second way to solve for how the measure of an angle. And here is the harder way, but some people do this because they don't do the simple way. Instead of reading 0, the top numbers are 180, and what's this number? 130. So what they would do is to figure out the distance from 180 to 130 is they would subtract. So 180 minus 130 is 50. So either way you get the same answer, but the easier thing to do is read 0 all the way to 50. Okay? There's a second way to do this, and it's with the absolute value. I do want you to write this down somewhere. To find the distance on a protractor, you would do the absolute value of the degrees. So I'll write you an example. If we did the top numbers here, looking at our angle, the top number at our first ray is 180. So if I did my 180, what number is the second ray at? Just give me an estimate, you think. Not 75. 75 is right here. 65 is right here.
66.
I would say 67. I would say. Okay, 67, give or take. So if you did 67 minus 180, here's the reason for the absolute value. If you just read it and started subtracting, is my answer without the absolute value bars, is my answer going to be positive or negative? It's going to be negative. It's going to be negative 113. But the absolute value bars are there just in case you put the small number first and the big number second. Because what's the absolute value of negative 113? 113 degrees. So again, you could have done it the easy way and read the 0, which is on the bottom, and gone all the way over here. Here's 110. It's not quite 115. It's not 114. It'd be about 113, 112. Okay, so if you didn't read the bottom, that's fine. You would just have to read the top. Here's the common mistake. People will read. I'll show you. All right, so everyone can see that this angle, the ray, is here. So people will read 0, and then they'll be like, oh, it's at, that 67 degrees. But what's the problem with this?
Oh, yeah.
If you read from the bottom the first time, you need to make sure the second time you do it, you also read from the bottom. Because does this angle look like it's 67 degrees?
Yes.
No, it does not. Because 90 degrees is a corner. So more than 90 would be like wider than a corner. All right, we're going to practice with the paper you have. So go ahead and look at that example. We have GHK. So, Lena, shh. Andrew, shush. All right, so here's my angle. It's in pink. It says find the measure and then classify. When you classify something, you're putting it into a category. You guys are in 10th grade. What's your classification? Sophomore, but those are the classifications of an angle. So you're thinking right. So you're going to find the measure and then classify it into acute, right, or obtuse. Okay? And we'll talk about those. We will review those. It's just this came before the review. Don't know why. It is what it is. All right, so my first ray, this bottom one, where is 0? Is it on the top or the bottom? The top. It's the top number. So when I get all the way to the other ray, I need to read the top numbers. Okay? It's not perfectly on 120. It's not perfectly on 130. Where does it really fall? 125. What's the distance between 0 and 125? 125. So would that be acute, right, or obtuse? Obtuse. All right, we're going to do the second one. We have J, H, L. All right, so looking at this ray, is 0 on the top or the bottom? It's on the bottom. So we'll read the bottom numbers this time. Go all the way here, and it's at 90. So 90 degrees, which makes it right angle. This last one is the hardest. I'll show you why. LHK looks like this. It doesn't start at 0. That's exactly right. So you would need to decide, am I going to read from the top or am I going to read from the bottom row? As a class, which one do we want? The bottom? Sure. So we're going to read from the bottom row. So that means we're going to read this 90. At this other angle, okay, the bottom row means it's between 60 and 50. All right, so what's between 60 and 50? 55. And here's 90. So we're going to subtract. So 90 minus 55. Again, you can use the absolute value bars, but 90 is bigger, so it's going to end up positive anyways. So we would get 35 degrees, which is acute. So even had you used the top would have been 90, and what's between 120 and 130? 125. So 125 minus 90 is still 35. Okay? So you still would have gotten the same answer had you used the top row instead. Questions about this? Okay. All right, congruent angles. Go to the next page. Some of you guys need to make sure you know what the congruent symbol is, because on the test I saw any variation from this. Oh, no, that's correct. I saw this, which looks like a sandwich. I saw this, which is approximately. I even saw this, which is nothing. So make sure you use the correct symbol, because the congruent symbol looks like this over here, with a squiggle, one squiggle, and an equal sign. Okay? You need to make sure if you're writing this, the measure of angle BAC equals the measure of angle DEF. This is what you'll normally see. Angle I can't read letters. Angle BAC is congruent to angle DEF. So there, you can write them either way, but this is the reason congruent was created, because it just takes so much longer to say the measures are equal instead of saying they're just congruent. They mean the same thing. This is just shorter. All right, we're going to do this quilt. So go ahead and look at this. Your picture looks a lot clearer than what is on my screen, because mine's in color, so it looks like a hot mess. But we can do it together. So you remember how when we had line segments, we would have like a dash to show that they were congruent? Yes, we remember? No, we remember. Yes. So you have something similar. These are these half circles, I would say. That's how you would tell that they're congruent. So this one up here, I highlighted it in orange. It has one curve mark. This one down here also has one curve mark. That makes them congruent to each other. That's how we mark them. So we need to write that they're congruent. So can someone name the top angle? Mason?
HGF.
HGF, and then throw it to a friend to name the other one. Throw it to anyone. There you go. Michaela. There you go. It's congruent to angle? CBA. Perfect. All right, and then there's a second set that's congruent. Can someone look at it and tell me it? You can throw it to Lena. CDA. There we go. Angle CDA, and it is congruent to. Throw it to someone. There you go. Kennedy?
HGF.
Close.
GFE.
Yeah, GFE. Angle GFE. We could also say EFG. All right, so we're almost there. Letter B says the measure of ADC, which is this angle right here. I don't know if y'all can see it. This angle is 140. What's the measure of EFG, which is this angle? Well, what do we notice about the two angles? They're congruent. They are obtuse, but they're also congruent. How do I know?
Because it has the two lines.
The two curve marks. Okay? That makes them congruent, so then what's the measure of EFG? Yep, 140. Questions on that? Yes, ma'am. Oh, the measure? The measure of EFG equals 140. So you wouldn't say congruent to, because this is the exact measure. You only use congruent when you're comparing. Yes, ma'am. Because it came right here. ADC, which is this one. Remember that you can flip the letters. ADC is congruent to EFG. So that means if one of them is 140, the other one is also 140. All right, angles can be classified according to their angles, or according to their measures. We're going to go through this really quickly. All right, what's the name of an angle that's less than 90? Acute. That's fine. We'll just do rapid fire. All right, 90 degrees. Right, just say it out loud. It's fine. Bigger than 90. Obtuse. This is where I remember obese. Okay, it's a bigger angle. All right. And then, what does this one look like? But what kind of line?
Line.
A straight line. So, straight angle. Sorry. All those were nice answers, but straight angle. I know you were. All right, we have one last postulate to learn. Sorry, we're on a little tight schedule here. If P is in the interior, and mine doesn't show up till the very end, so I have to keep writing it. If P is on the interior of angle RST, so here's what I'll tell you. Do you remember where we had, who plays football in here? I forget who we said. Jerron, how far did Jerron run out of the 100 yards of a field?
20.
So if he ran 20, how much further, listen, how much further did he have to run? 80. It's going to be the same concept. If the whole angle is 100 and you already have 20 degrees found, to find the other, you do the same thing. Okay, so these are the same concepts. You just are going to have it in an angle instead of on a line. All right, so that's why I have faith that we're going to get through this. So here's what you want to fill in the blank at the bottom. Go back. All right, so we have the measure of RSP plus the measure of PST equals the measure of RST. So when you add the two angles together, you get the outer angle. Just like when we add the two segments of the field, we get the whole length of the field. I'll show you with numbers. Let's say that RSP was 36 and PST was 38. How would I find the measure of the entire angle, RST? Add them. So you would say RST is equal to 36 plus 38. You'd get 74. All right, this is where we do our last two examples. They're on your notes. We're almost there, folks. Oh, my goodness.
It's
It's right there. Yep. All right, so we're going to find KLM. Remember that whatever I do, you should probably do on your paper. So I'm going to draw inside of the angles, and it helps you see what you need to do. You have KLB, which is 26. So I write 26 inside of the angles. Okay, it helps me see that this little piece is wedged right here is 26 degrees. Then it says BLM is 60. So then how do we find the measure of the outer angle? You add them. 26 plus 60 equals 86 degrees. Ta-da! The same with the last. We're finding FGH. FGB is 105. BGH is 54. So we're going to add them. 105 plus 54 is 159 degrees. Perfection. So this is getting us ready for tomorrow's lesson, because this lesson was broken in half. This is the first half. All of tomorrow is over this, but algebra gets thrown in. So like x plus 2 and things like that. Alright, we're going to go over the frequently asked questions. The sides of an angle are made up of what?
Rays.
Rays. Perfect. What's the name of an angle that measures 180?
Obtuse.
Obtuse.
You're wrong.
Wait,
Straight. So, more than 90, less than 180. I don't know why your desk is cleared. You still have 3 minutes
Miss
left.
Marshall,
Yes, ma'am.
can I have Andrew McCrary to the S building office, please?
Yes, ma'am. One way to make your math teacher ticked off is if you just sit there and do nothing while I'm literally doing this. What's the name of an angle that measures 90? Right. You're good. The last part you're doing is the review. This is what you're doing for the remaining of class. You will not get any fractions. No fractions. And then you need to remember parentheses, exponents, multiplication, division, addition, subtraction. You will not get any fractions. Do you understand?
Yes, ma'am.
So if you get a fraction as an answer, you either did something wrong or you haven't simplified it. Okay?